Okay, in this video, I wanted to show you an example, a really good example actually, of a computer adaptive test. And the website, I put a link on the homepage. It is echo.edres.org:8080 /scripts/cat/startcat2.htm. So anyway, it's a kind of an old school website. Clearly, it's not got any of the modern kind of look and feel, but it really has a tremendous amount of information on here, and it shows you exactly what's happening with a cat as you walk through it step by step. So it's a little bit complicated, so I want to make a video about how it works, just to kind of show you. And then I encourage you to play around with it because it'll give you a really good idea what the algorithms are doing and things like that. So to start, it gives you three different choices of metric for ability. And we're going to use the z-score unit because it looks a lot like theta that we've been talking about all semester. And so I think it's the most intuitive that way. But it also will kind of transform that into SAT type units or percentiles or what have you. And we're going to choose our true ability. So the idea is we pick an ability, and as we go through the cat, we're going to respond to it, and we'll see how that cat kind of hones in on this ability estimate as it goes through different items. So that's the plan here. I'm going to keep it at the default of a zero point 0.5 theta. We're going to, it says z-score. We're going to just call this theta, make it easy. And I'm going to click get started. And let's take a look at what it does then. So it first presents us an item. And so, looking at it from the perspective of the cat, for the first item, it has no idea what our ability is, right? It doesn't know what our ability is. And we're going to take a look at all the graphs and things like that in just a moment. So it presents us to start with an item kind of directly in the middle. So if you look down here, the summary information shows you your current ability estimate, and it says your true ability, and it gives you both the percentile and the z-score. We chose the z-score, which is essentially like a theta metric. So that's what we're going to look at. You can ignore the percentile over here where my mouse is, and you can see it's got our current ability estimate at 0. Are true, unknown to the computers. The cat's ability at zero point 0.5, and the standard error currently is, of course, enormous at 6. So basically, what's it doing? Well, it's showing our original ability estimate at 0, and it's starting the kind of the flow chart and saying, well, let's pick an item that maximizes information at an ability of 0. And this is the item that it chose. And these are the items it was choosing from. So you can see what it was doing. It was computing item information functions at different thetas or z-scores, right? And we'll just call it theta just to keep it simple. At different thetas for different items. So there's several different items kind of pictured here in this graph. It's a little a little bit rustic looking, but you can see it there. And what it did is it chose the item that has the most information at this theta of 0, and that's the item we are looking at. It also shows you the item response function or the item characteristic curve, and it shows you that at a theta, true theta, zero point 0.5, which is what our true theta is, we should have about an 80% chance to get this item correct, right? Or 0.82 to be technical. So if you look over here, what it's doing is it's presenting the item to us, and it's giving us the item response options, and it's telling us which one's correct. That's what those two little asterisks are there. It's also choosing that one for us, because what it did is it's showing you different parts of the process, right? So it's showing you first off how the cat chose an item. It chose it based on item response functions from different candidate items, and it picked the one that's highest. And then it says, well, we have to make a response here. And it's telling us here that, well, given our true theta, right, we should probably get this item right if we want the cat to do what it's supposed to do. Now, we don't have to choose the right response. We can choose the wrong response, and you can see what happens. And I encourage you to do that when you play around with it. But to start, for the first time through, we're going to choose the right response because that's what it's recommending. And knowing what our true theta is, right, we have a 0.82 chance of getting the item right. So let's just make it the right response. So when we do that and click submit, let's take a look what we've got down here. So what you can see now is we've had exactly one item and we got it right. So the current ability estimate jumped from 0 to 3.0, which is really high, right? So what the algorithm's doing is it's saying, okay, we think this person's got an ability of 3. What item has the maximum information at a theta of 3? And you can see that blue line is the item that best maximizes information when theta is way over here at 3, right? And that's the item we see here. So it's a rectangular carpet, 9 feet long, 6 feet wide. What's the area of the carpet? So it's a fairly difficult item, as you can see. You can take a look at the item parameters down here. It's got a high A parameter, which is, to be expected if it's generating the most information. And it's got a B parameter of 2.041 and a low C parameter. So, again, a lot of information there. And based on this item, right, we actually, if you look at the ICC down here, our theta is actually 0.5. So this item is way harder than our true theta is. So we're likely to miss this item. And the probability, if you trace this over, is 0.15, and they write it for you right here. So it's telling us, hey, you should probably pick the wrong item here if you want the cat to work, because it's unlikely in reality we would get this item given our low, meager 0.5 theta. So I'm going to choose the wrong response. It doesn't matter which one. I'm going to click submit. And you can see now, if I scroll down a little bit, that our current ability estimate jumped way back to negative 3, negative 3.0. And so now it thinks we're really low in ability. So what it's doing again is going over to look at the candidate items and finding the item that has the lowest or the maximum information at a theta of negative 3, which is quite low. And this is the item it picks. And you can see here the item characteristic curves. A is 1.02. The B is way down at negative 3.958. So this is a really easy item. And you can see, given our true score, our true theta, right, we have an excellent chance of getting this item right. We have a 0.99 chance. So we're going to go ahead and click this one too. And you get an idea for what we're doing here. You can see now our current ability is actually not that far off. It's 1.06. Right, so it's well above what it was previously, not that far off from our true ability, which is our true theta is 0.5. And the item, what it does, same thing, it looks at all the different items in the item bank and picks the one that's got the most information at a theta of this current ability estimate, 1.06. And you can see it's this blue one here highlighted. This is the item. Line segment's perpendicular. And then it's figuring out, well, given this item and the item parameters are an A of 3, which is really high, and a B parameter of 1.16, we're actually somewhat unlikely to get this item right. It's 0.16. So it's going to have us miss this item too. So again, what it's doing is it's basically just having us respond the way that we are most likely to respond, right? Either correct or incorrect. We're most likely going to be incorrect. So it's just having us do that. We're just going to go with that. And we're going to click through just a couple more of these. You get a pretty good idea now how this works. And we can take a look at our current ability estimates at 0.56, which is pretty close. The standard error is 0.3, which is actually not bad, right? So that means if you think about one standard deviation there, it'd be 0.2 to 0.8 or something. So, it's zeroing in on our true ability estimate. And the standard error, you can see, it will drop with every item we click through, right? So standard error always goes down, presuming we're not responding in a wacky way and kind of, doing something really weird. So you can see, again, the ability is kind of being honed as we go through here. 0.57, standard error is getting lower and lower. 0.63 bounces around a little bit, still overestimating a bit. But we've only gone through, about 15 items. This is number 15 right here. And after 15 items, which is not a lot of items, we're within 0.04 of our true ability. And the standard error is only 0.18, so it's pretty close. So it's a good example of how CAT works. I think it shows pretty well, how that works. The other graph I didn't show you before is the distribution of ability and z-scores, and the red line is the true ability, and the yellow band is standard error. So if we go back and start this over, what you'll see is this hops around a bit, and the standard error, these little bars, get closer and closer in to the middle. And at this point, it may not do that anymore, but we can still play around with that a bit. And hopefully after about 20-ish items here, we're pretty close to converging. The ability, again, it's pretty close. Standard error is pretty close. And so we've got a pretty good estimate here. And I just wanted to walk you through that because, again, there's a lot going on here and a lot to understand. But just know that this is the part that the CAT's doing, the item information. This part's really just computing the p-value given our known theta, which is not something a CAT knows, right? If you're building a CAT algorithm, you don't have this part of it because you don't know what the true is. It just has to do something to recommend us to get the item right or wrong. And this is what it's doing to recommend that.